Howdy boys and girls, how are we? Got me a cup of tea and I'm good to go. So today we've got a Hughes and Kettner Puretone combo. Again, tell me if the sound's playing up or anything. It looks pretty good in this end. And check it out, I figured out how to rotate the video so now you don't have to read my multimeters upside down. How good is that? And it fits nice with my little screen there. Yeah, so we've got the two multimeters here which are hooked up to the bias probes of the EL34 output valves. That is monitoring the anode current, and we're tapping off one of the anodes here. That's going to the third multimeter, or the first in this angle. And that's measuring the plate voltage with reference to ground, and the ground is just connected to the safety earth lug in the corner near the mains entry using my fancy silicon lead that I like making leads out of. It's good stuff. So this amp I believe the owner has owned since new, and it started doing the old snap, crackle and pop, losing a bit of headroom as well. It's not the most powerful amp. I think there's 30 watts or something because it's cathode biased, and it's a well built, good quality amp. They've used F&T caps because it's German and F&T's German. But even these have started leaking physically out of the ends, the terminals. Let's see if I can zoom in on that. You can see shmoo coming out the ends there. That doesn't normally happen to the F&Ts, but this amp's running very hot. As you'll see in a second, the output valves are running at around 115, 120% safe dissipation, so they're emitting a lot of heat, and this thing is in a cabinet with a panel at the back of it, and there's not a hell of a lot of airflow in this unit, so I've got a feeling these caps are getting cooked by the thing over dissipating and running way hotter than it should be. It's an interesting design. It's got a step attenuator, so it's got full output and then 2 levels of attenuation. That's actually using an L-pad on the secondary of the output transformer. So it's like having one of those external attenuators. It's I haven't done the math here, but it looks to be like a 1 in 10 power reducer, which gives you about perceptive half volume. The half power switches that you often find that either cut out 2 of the valves or run them in triode or whatever, you reduce the power of the output stage by 50%. You only get about 3 dB of attenuation. It's not really noticeable. You lose a bit of headroom, and the amp reacts differently, but there's not a massive difference in volume when the thing's dimed, whereas a 1 in 10 is about 50% perceptible volume. I need another coffee, eh? So let's fire it up, and I'll show you the symptoms anyway, as reported. Now it's got it's a little bit gimmicky. The Hughes and Kettner have a massive hard-on for these acrylic illuminated front panels. Let me turn the light off so you can see it a bit better. Oh, there's the noise. So it's got an acrylic. I'll just turn it on standby here so we're not annoyed by the crackling. So it's got this is, I think, early to mid 90s. I haven't done a lot of research on the background of it, but I think from memory they're about early to mid 90s, and that was sort of before LED technology was really efficient and cheap, and like had the illumination. So they use cold cathode fluorescent tubes, and you can see them down the bottom there. They're flickery, and really annoyingly flickery at 50 hertz, which you can't really see in the video because it's 25 frames per second, but it's really distracting. They're flickering, and they're little vacuum tubes down the bottom there. They're the ones that the computer nerds, the overclockers and that, used to illuminate their desktop PCs with, the gaming rigs. and it's got, they run on high voltage, so there's two little inverters down there, either in either corner. You can see down there, and they've got little boost converters in there, and they're well, not boost converters, it's an inverter, so it's jacking up the voltage via a tiny little transformer. And yeah, so they've got little silicon wires running down there, probably, I'm not sure the voltage, I think it's a couple of 100 volts, and yeah, really flickery and annoying, but there's no problem with them. It's working as it's always been, and the owner didn't complain about that, so I guess he doesn't mind. But just these acrylic fronts in general, they look good in the shop when they're new, but they start to look pretty tacky after a while because they get shit in between them. They're just sandwiched on with screws to a polished stainless back, and the back of the acrylic is etched so it glows in the light, and you can see the label and the knob markings and whatever on there. And it looks cool in the shop, but over time you get shmoo in there and dust and stuff, and it starts to look pretty manky. And it makes it a pain in the ass because you can't access the knobs to lever them off if they're a bit tight, which these I bet will be. So I'll take that panel off, and then we'll work on it just with the stainless. But yeah, it's interesting seeing the high voltage supplies there. Anyway, let's fire it up. I'll just go full output. Oh, yes, there's lots of hissing and crackling and popping there. That's everything at 12 o'clock. So a fair bit of fluctuation there. You can see the turning down the volume reduces it but doesn't get rid of it, and that volume is after the first stage, so V1A. Now the only schematic I've got isn't exactly as this amp is, but it's pretty close. It's got another knob called Growl. Now you turn both of them down all the way, and that reduces it a bit too, but doesn't kill it completely. You'd expect an amp with everything turned down would be dead quiet, you know, and this isn't. So just crank it right up, and some hum comes in there as well. I've got to actually sort of shout over that. Sounds like there could be some leakage happening there too, but that pot is sort of all on or all off at the start too, so that could just be the taper, but it could be dirty. It could be DC leaking has actually caused a break in the track, but we'll suss that out. They're just 16mm generic pots. They've got the little frames either side, but they're bolted to the front chassis, so we can replace them, no problems. So yeah, you can see the bias there. We're running about 58 milliamps per side. Reasonably balanced, but at 470 on the plates, we're drawing about 110 watts from the mains, and that's idle. There's no adjustment on this, obviously, because it's cathode biased. So I wouldn't mind cooling that down, because that's around 115-ish%. 120, well, depending on the mains. What's the mains at today? 245 volts. So that's doing some weird stuff now. It's kind of cool. It's giving us coded messages. What I might do also, I'll disconnect those inverters and make sure that's not getting any weird noises from that circuit as well. So I'll power it down and unplug it for that. We've got our B plus sitting at around 3 volts. Just isolate them for now. just take one more thing out of the equation that could be causing noises. I dare say it's the valves, the preamp valves causing that problem, because the volume control affects it. Alright, so we've got just the lamp now, which in my opinion looks better. Not the full-on Vegas light show happening. Alright, let's fire it up. Same shit. Oh, it's turning into a drum machine. Right, so easiest thing first. I mean, there's some stuff we've got to do. We've got to cool down the bias and we've got to recap it because they're physically leaking. But let's just figure out what's causing these noises if it's not those problems first. And the easiest thing to do, change a couple of valves out. So let's give that a go first. There were JJ's in there. JJ's going back in. They seem to be the most reliable at the moment of all the valve brands, but you know, that could change overnight. That's the right 6, I don't need schematics, it's simple as. I've traced it with my eyes already. So let's fire it up with the new preamp valves in there. Warming, cup of tea time. Alright. It's a lot quieter. Still a bit of hum. That's maxed out, so it's going to be hissy maxed out. But having said that, again, we've got carbon film resistors on the plates. We can replace them with metal film and get that noise right down. It's not like it's a classic amp that's got carbon comps and it's historically significant or anything like that. We're just after good low noise floor, and they're only metal carbon films in there anyway, so we'll replace them with some metal films. It's got metal, looks like metal film droppers between the supply nodes, but on the plates it's got carbon films, so we'll change them out. But we'll go through the circuit a bit more in detail. So that's calmed it down a lot. Almost sounds like the pot's working more gradually there too, so could have been some DC on it. Let's give it a little bit of signal. Turn the output down so I don't deafen you. Yeah, see, it's still coming in pretty abrupt, but that's a solid, well, that's a solid sine wave. It's not you playing guitar. It's not like you sit there twiddling the volume knob while you're playing. You'd have to have 3 arms, right? Let's give it a bit of guitar. You get to listen to my terrible playing. There's my pick. Alrighty. So the output stage is still running a bit hot, but it's not running away or anything, so just keep an eye on it and let me know if it does, eh? So we're running into an Eminence something or other. Legend. Sitting right next to it, so of course there's going to be some hum. So Okay. So the growl just seems to be like a mid boost. I'll have to suss out exactly what that's doing, but so all in all, it's not performing too badly. Just a little bit of hum, a little bit of hiss. So the majority of the problems are those preamp valves. I haven't sussed out if one or the other is the problem. I'd say it's the first preamp valve, V1, is the main issue. But he did say he wants it, you know, proper serviced and replace all the valves, so we'll do that. These look like they've copped a fair bit of heat. They're probably still fine. If we cool that bias down, they'll probably live a longer life, but he just wanted them changed out, and he can keep them as spares and just chuck them in the box. And being cathode bias, he doesn't have to stress too much about popping them in. I'm going to cool it down a little bit anyway by changing the resistor values. It's already got 1K screen grids in there, so that's probably why they've lived this long. But yeah, we're going to change all the caps and cool the bias down a little bit, and just see if there's any other things that need addressing along the way, and change the plate loads as well. I mean, that's cranked. That's 12 o'clock. And it's really loud. Oh, something's happened. One of the valves just dropped out. Shit. Okay, another problem. What's going on there? So now, let me just need another meter really. So just cranking it up a little bit there, and it's one of the valves has completely stopped conducting. So I might power it down, take a few measurements, and the plot thickens. Nothing's ever easy, eh? I thought it started sounding a bit different then when I was playing, just briefly. The plate voltage is down, so I'll just plug that straight in, and then I'll measure the ground with the one that was monitoring the B+. Measure resistance to ground, measure the cathode resistor, 470, okay. So what we might do, I'll power it back on again, and we'll just see if the screen grid resistors dropped out perhaps. It might just be the valve. See, that one's coming up. Oh, that one's coming up, that one's not. So we'll go to DC volts, measure this side, 360, measure the other side, 410, measure that side, 403, the other side, 410. So that's fine. We've got plate voltage there, 480. We've got plate voltage there, 470, 480. So, busted valve. Unless it's the probe. Still feels warm. Maybe it's a problem between the steering wheel and the driver's seat. Heaters are glowing. Okay, I don't know what's going on here, because that feels to me like it's still conducting, still generating as much heat as the other. So I think my probe might have an issue. Let's just swap the probes over. Let's just swap the valves over, right? That's easier. That's a good point. I could have blown a fuse. Let's check that straight away. 400 milliamps? Really? But that would have broken the anode connection, and it would not be dissipating at all. Could have just been residual heat. Let's just check that. Continuity. You fucking asshole. Blown fuse. They're fucking expensive too. Damn it. I've got a spare though. So you see this one here, doesn't matter what setting it's at, there's still a fuse there. So that there is reading that's showing that the fuse is intact, and it's just showing the shunt resistance of like an ohm. And that one's showing fuck all. So we get to fix my multimeter as well, and I think we'll change it to the 10 amp setting, eh? Alright, well, we've got to fix that. So let's do that first. We'll disconnect this. It's one of those days, eh? That's never happened before, you know, from measuring just anode current. Well, you know, you get to learn how to change a fuse in a Fluke as well, hey? Let's zoom in on it. Get the light going again. So, Fluke. Fluke 179. Great multimeter, but not when you abuse them. Open up the clamshell. Is there another screw there? No. There she goes. So there's the two fuses there. Bit of dusty schmoo in there. We'll clean that out while we're in there. There's my compressor orb. So we've got two fuses, one's for the 10 amp, one's for the 400 milliamp inputs. Jesus, this thing's dirty. So this is how a simple job turns into a 2-hour job. Well, you're there, you may as well clean the thing, eh? Never been opened since it was new. The battery's still fine. I'll have to dig out. That's the 10 amp fuse, I believe. 11 amp. People often ask what's a good cheap multimeter. Just don't buy them. Just get a good one. If you're going to have 1 meter, get a decent one. There's a spare one from, oh, was it RS? Looks like an RS components code. Don't know. Anyway, they can be really expensive if you get them from the wrong place. They are made to deal with high braking capacity. That's why they're so big. And they also are made from fiberglass. So the glass ones can explode inside your meter. And when they explode, if you abuse them or do something really stupid with them, it's a level of safety. So the glass ones, they can explode, and they explode because there's vaporized metal in there that's trying to increase in volume exponentially as it vaporizes. And when it vaporizes, it also condenses when it cools down, and it cools down on the inside of your meter in various places. That forms a conductive path for whatever fault you've just caused by putting your meter in the wrong place, and it allows the current to keep flowing through your meter, explode it, possibly explode your hand, catch fire, arc flash, all sorts of horrible shit. That doesn't really apply to us in the amp and audio repair field, but to Sparkies, anything where there's unbridled power available, like, I don't know, mains, particularly anything industrial, it's super, super dangerous to throw anything in there other than an approved fuse that's designed for the job. But as Six says, you're working on secondaries of power transformers, and everything's current limited anyway to whatever your breaker box is, and usually that's what, 10 amps. It's still not advisable, but hey, everyone does it. But you know, I like having the official one in there, and it's just one more thing that I don't have to worry about. So that's a Bussmann 1000 volts fast acting fuse, DMM-44, and that is 10 kiloamp breaking capacity at 1000 volts. So it can break 10,000 amps, and it's 440 milliamp rated. So I'll pop one of them in there. Put the new. Put the buttons back in. They're starting to wear down. Put that back on. Screw it back together. So we just had our lockdown extended by another week, which isn't great, but it's better than just running around like dickheads when there's vulnerable people out there. And it gives me time to just concentrate on work, which is fine. The retail side's taken a hit, but that's never really been big here anyway. It's just been a bit of a side thing, whereas repair's the core business here. So let's try that again. I've got to get all my shit organised again. Joy. Just test that is fine, just to show you. Got the other meter set on continuity. We'll set this. Well, it doesn't matter what it's set to, I'll just demonstrate that too. So you got continuity on the 400 milliamp and continuity on the 10 amp now, where we didn't before. So where were we? Let's get the camera back in line. Get the meters back in line. Put them on the 10 amp, hey? I don't think accuracy is that important in this situation. Piss the leads off. So we'll just keep an eye on the plate voltage. Put the ground connection back on. We'll sort our shit out. Alright, where were we? Still got the speaker plugged in, always check that, it's easy to forget. Plug the mains in. Standby power off, power on. Yeah, if there was a shorted element in the fuse 6, being a cathode biased, I don't think it would have. Well, it still, yeah, would have blown the fuse, but I don't think it's going to blow the 10 amp one. I think we'll be able to switch it on temporarily and have a look, make sure everything's cool. Alright, pucker up. So we're not drawing excessive current there. Wait for the voltage to drop. I just put it back into standby. Put it back into 400 milliamps. Try again. Okay, yeah, so that's calmed down. I think we just shot a bit through, too much current through it while we were playing because it was cranked. Either way, we're changing the valves. You can keep these as spares, but yeah. We'll see. Alright, well, let's get to work, I think. We know what we've got to do. Those two valves are staying in. Well, alright, let's try one of them in the phase inverter. We'll see if just that first one needs changing. So that's one of the old ones, not sure which. Let it heat up. So that's sounding okay. First stage is always a bit microphonic when stuff's cranked. But I think that one's, well, it's okay in that position. See, I don't think that's probably not this one being microphonic, it's just going through the chassis to this one. But yeah, we'll try the other one out and see if it's got any obvious issues in that position. Might be able to just mark one as completely bad and just give him the other one as a spare. Okay, so that crackling and shit's back. So even in the phase inverter, well, it's got higher plate voltage there, so any issues in the first position will be probably more obvious in that position. So that's the buggered one. The other one he can have as a spare, so I'll rub the texture off that one. Put this one in, that's the new one. Put that one back in the box. Label it spare. Wrap a bit of tape around this one. And mark it non-functional. non-functional. So bad to the bone. Alright, so we've sussed out the preamp, and let's power it all down. Let's just unplug it. Plate voltage is dropped. Some amps don't have bleed resistors on the capacitors, so you do have to check the just double check your plate voltage. Well, check your reservoir caps as well. Check that your standby is on. If you turn your standby off, that can cut off the reservoir caps. They can hold charge regardless of the B plus being powered or not. Just be super careful. Last resort, just go through and put the probes on every cap and just check them. It takes like 30 seconds. Good idea to completely isolate everything except the cap too, just to make sure. So don't go off your ground clip. Actually put both probes on both terminals of the cap. They're reading maximum 1.5 volts, so we're safe. So let's disconnect these probes. They're still a bit warm, but we're pretty tough, so we're good. It's really cool when you unplug a valve while the heater's still warmed up and it's glowing and it's in your hand. You feel like a superhero. Yeah. So let's remove this front panel. Let's get the valves out before we smash them. I'll just mark them as good and put them in the good box. We've got a 3mm Allen key driver bit to remove the countersunk metric stainless Allen key front panel screws. A bit fancy. German engineering, German engineering. Be careful of those compact fluorescents so that we don't smash them. I can see that happening. Someone's trying to ring me. Call you back. Core of the knob glued with mouldy ass looking glue. Just slipped out. German engineering. Cut a few corners. Have to glue them back in. Can leave the switches on. Basically I want to get this board out and flip it up this way to access the bottom to replace the caps, because I'm not a fan of janking stuff on the existing leads. They overheat when you're soldering them, and you can break the solder connection, which isn't great. 10mm, 11mm, 10mm. Input jack passes under the board to the other side. Pop all the fasteners in a separate box. Bugger, I'm gonna go in that box. Right, now this board has got just like nylon standoffs. Now someone's very persistent, still trying to ring me. Don't you know I'm a YouTube celebrity? Oh. So everything's a bit stiff there. So it's a matter of what's holding it back. It's probably a bit of this, bit of that. I'll just back off, get rid of these clips. Here we go. It's just the standoffs holding it in place. So, that's interesting. Looks like some rework has occurred around the cathode resistors. Try and show you. So they've got those brass rivety things, but then they've passed the lead through and they've scratched away some trace and soldered it nearby. So that's the ground plane there, and then that's the cathode connections. Just seems like an odd way of doing it. The resistors are particularly long for a they look the size of a 5 watt but a little bit longer, so it's got a 6 on there, so I dare say they're 6 watters. And we'll replace them with 7s. On the schematic, it's just showing 5 watters. 5's probably adequate. Yeah, some funny stuff. Looks like, you know, stuff that everything's sort of got a general sort of standard about it, but then you know, 1 or 2 things don't sort of line up with that standard. So yeah, I think some rework may have happened here in the past. It's hard to tell. It's kind of a bit of a weird amp. It's cool, but it's just a bit, construction method's a bit strange, but the earlier Hughes and Kettners were a bit strange. So I keep getting phone calls from someone, so I'm just going to mute you and Sorry about that, people. Business. The joys of business. So I'll get rid of the control panel. Let's get started on this thing. So, we know what we've got to do. We've got to replace the capacitors, the electrolytic capacitors. Now, this is a bit strange. It's got bipolar capacitors in the output stage bypass caps. That's not really required. And they are leaking as well. And the bias supply as well has, not bias supply, sorry, it's friggin' cathode biased. It's, where is it? So it's got 22, yeah, it's got a 22 microfarad 100 volt for V1B bypass cap. It's got 1.4 volts on it. That's a bit of an overkill, don't you think? So we'll replace them with some more logical values. So I'll probably go 50 volts on the outputs and then 25, 35. I think I got 35 volt in stock for the V1B bypass cap. There's some funny solder joints in there, like balled up things. And the rest of them looks wave soldered, or at least competently soldered. And then there's the occasional big ball of goo on there. And that's located around one of the coax cables. So I wonder if that's been removed at some point. Or changed to coax. It might have been just unshielded cable and they had hum issues, so maybe one of the revisions was change that grid input. 1, 2, 3, but it's not the grid. It's bloody... Oh, sorry, yes it is. I'm looking the wrong way around. And yeah, they might have changed that to coax at some point to try and address some noise issues. It's got another little power supply there that goes to the what am I trying to say? Goes to the cathode cold, the fluorescent tubing power supply. Jesus, sorry. All right, let's just go snippety snip, eh? All the markings on the circuit board are as per the caps that are in there. Sometimes they put them on the silk screens back to front to try and give you a bum steer. You can see right here on one of the output stage bypass caps, there's some shmoo leaking out around the seal. So that cap's on the way out. Now bipolar caps are essentially two normal caps back to back, so none of them get exposed to DC. And they're not required here because they're constantly biased, so I guess you could say. So there's no need for bipolars there, and bipolars, because they're two caps back to back, essentially they're twice as big. This is tricky. I like to cut the caps off so you're not trying to physically remove the cap at the same time you're desoldering it, because that can damage the circuit board. Still zoomed in there, sorry about that. In the bin. Now, I don't think it's going to be easy to get to the... Oh no, that's alright. Never mind. Alright, so they're all chopped. Break the silicon join. Use silicon, not hot glue. Take note, PV. Right, axials removed. Now, let's suss out which of the plate resistors. So they've got red wire coming from there to pin 1 and pin 6, pin 1, pin 6. So that's the supply. Phase inverter and V2B are running off the same node. Is that correct? Just tracing it out visually here. And then V1A is running off another node, its own node. So that's one there. Sorry, a bit of a cognitive silence here while I'm tracing the circuit out in my head. Oh, God. There's no component markings on this circuit board. So you've literally got to look at the circuit board and create a schematic in your head while you're looking at it, which is fun. So what's everyone doing on this fine lockdown Thursday? My Sydney brethren, anyway. Not brethren, nothing religious. So I'm just desoldering the leads from the filter caps, which I've snipped off. Oh, I forgot about my new buffer. How could I forget the boffer? There we go. You get to get deafened by the boffer. Sitting in the timber yard. Do you work in a timber yard, or are you a truckie? Just clean the tip. Because it's sucking the excess lead up through the nozzle as well at the same time. Got to clean it after every 1 or 2, otherwise it gets jammed full of crap. So you've got the lead stuck in there now. I really should remove them with tweezers before doing the extractor thingy, but you know me. You're a truckie. Which timber yard are you at? Harper's? Matthews? Trend? Nah. Warragamba? I've seen them all, mate. I'm a joiner by trade, so often I had to go scrounging for or selecting timber. Got a forklift license too, which probably lapsed now, but a wood machinist. For some reason I decided to do this in Marrickville. Must be a pretty hoity-toity timber yard being in Marrickville if you can still afford rent. Used to go to Anagoat a fair bit as well, wherever they are. I think they're down southwest Sydney somewhere. Give them the old joke, I'll have some timber and a goat. I wonder how many times I've heard that. Sometimes you just got to pop a bit more solder on there to get it feeling you. Pretty decent quality board though. It's through hole plated. It's 1.6 mil FR4. Ah, come on, you bastard! Right, what I might do is I'll do what I should have done the whole time and take out the excess lead with tweezers while I'm heating it up to avoid damaging the pads. Alright. Heat this one from underneath. A bit more solder. And remove the lead, excess lead with the tweezers. There we go. A bit of crap. Last one. I'm going to clean off the silicon. So I hope you're all enjoying the Bob Ross of electronics. Is it lunchtime yet? I'm hungry. Alright, so let's get rid of the boffer. Scrape up some silicon, eh? It's got a Stanley blade, nothing fancy here. Again, I forgot my friggin' chisels. Actually, I might grab the marking knife. It's got a bit of a handle on it. Wherever it is. There it is. Tools out of the way. Better. Yeah, I'm probably out of the shot. Yeah, of course. Never cut towards yourself. Do as I say, do as I do. Get rid of the excess silicon. The new silicon sticks to the old silicon, but we'll just get rid of most of it so it looks nice instead of having massive bulges of silicon coming out of the thing. Really wish I brought my chisels home. I mean to work. Well, yeah, home. It was interesting. I called a sales rep the other day. Just a friendly, you know, just getting hit up by the customer about this, just wondering what the ETA is. And he's really defensive. It's like, yeah, mate, I've got a lot of emails I've got to get through today. You're just one of them. I'm like, fucking, whoa, hang on. Like, I get every day probably 6 phone calls or emails or whatever asking about an update of a job. Like, it's just part and parcel of dealing with the public. Like, they don't realise that you've got other jobs. But yeah, this guy is like, and I went so gentle to him as well, and he was really seemed really stressed out. It's like, fuck, man, maybe you need another job. I think you've got to be sort of born to be a rep. It's not something you can just jump into. You have a thick skin. And a high tolerance for dickheads like me. So little gotcha on this one is the only caps, the decent quality, that are axial, that are 500 volt and they're around 30 microfarad at the moment are the F&Ts this way, and you sort of got to take what you can get. Now, yeah, they're F&Ts and yeah, they're quality, but these are 33 mic, different series, older. Generally, newer caps are smaller. As the technology gets better, they figure out ways to make them basically more compact. Why are you focusing on background shit when I'm right here in the foreground, you stupid fucking camera? It's having problems with the reflection, I think. Yeah, so the new caps are slightly bigger diameter and slightly longer length. The length isn't an issue because there's plenty of tolerance there. But those caps in there were mounted real snug right up next to each other. Now I know it shows a gap on the silk screen, but that didn't exist in real life. They were hard up next to each other, all four of them. So the old ones were 21mm and the new ones are 25mm. Doesn't sound like a lot, 4mm, but it adds up over 4 caps. So we've got to sort of do the Hughes and Kettner, fucking Gallien-Kruger thing, where we do a run of caps, every other one, and then the other two sit slightly elevated, and we silicon them together, and the leads run all the way down to the board. If you do it right, it ends up looking fine, and it's just as secure as it would have been otherwise. But yeah, it's just strange that these are 30, so if anything they're 3 microfarad less and they're bigger. So I'll just mock them up before we put silicon on there, make sure it's all going to work. It's always good to do a dry run. Learned that from my cabinet making days. Do not involve glue until you're 100% happy with the joint. It's one of those ones you have to learn the hard way, otherwise you'll never learn it. 30 or 30, that's a 220 for the reservoir. So we'll go every second one. It's still soldering that hole. Come on, you asshole. Get the excessive solder out of a through hole. Sometimes you've got to add a bit more solder, particularly when there's ground plane on the bottom, as there is in this case. Here we go. So, zoom out a bit again. I keep forgetting to look at the camera. It's not like I'm making a video or nothing. So we'll put every second cap in. So just those two. Might have to loosen up some of that wiring for access. Yeah, maybe not. We'll put every other cap in. See how they sit. So I'm envisaging something like that. Ah, come on, you fucker. Something like that. I think that's the way we're going to have to roll. So just looking there, a little bit, we'll get the alignment spot on, but something like that in order to fit them all with a larger diameter, and the silicon will be holding them together. It's either that or we've got to go 22 mic caps, and that's not as per the schematic, which wouldn't make a massive difference, but It's not on the B plus. It's on the phase inverter. Sorry, the screen grid node anyway. And then the preamp nodes, the filtering's way excessive in what it needs to be. But hey, we've got 30s, so we'll put 30s in there. So we've got those 4. Just get rid of the excessive solder here. No, there's a ground plane on the other side, so it will not melt. Have to access it from the ground plane side. It's really messy. Alright, we've got our 220s. They're going to be fine. Bit of silicon. Again, we just put them with the value pointing up, so you can quickly confirm that the value is correct. Other text and whatnot in the future. One facing one way, one facing the other way. Just a schmear like that. Nothing major. Not building a wall out of it. Shore up those leads, everything's cool. Just push them down, fold the leads over, solder them, get the buffer going, because why not? It's not doing much there. Sweet as. Pop one of those wires out. To reconnect that properly, it was just sitting barely, not even in the hole. Did one next to it too. There we go. Better. Snip those leads off. Now, before we get on with this, I want to have that sort of as the last thing that I do. So let's do the bypass caps first. Now there's a film bypass cap for the first stage. It's a 0.68, 63 volter, which is don't know. Is that it? Where's the cathode? V1A. V1A. Oh, it's mounted on the valve socket. Yeah, there it is. Okay, sorry, I'm making you look at my bald head again. I know it's not pretty. I've got to live with it. So I'll get some bypass caps. Alright, so we've got two 22 microfarad 50 volts for the output stage. Massive overkill, but it just looks comical having such a tiny cap there. So, even though it's the same size there. But we'll put the 20, we've got a 35 volter for the V1B triode. That's the smallest voltage I've got, and that's the last of those niche cons because they're obsolete now. Unfortunately, they're really good caps and reasonably priced. Now we've got to go with V-Shay or, God forbid, IC. Tip's a bit blocked. It's whistly. Should sound like that. Alright, we'll pop in that cap. Don't need silicon for this one because it's tiny. Just got to get the lead spacing right. When you do a gentle curve like that, you can tweak it without making it obvious that you've done so, just by folding it over a little bit more. If you do a hard fold with pliers or something, it kinks it, and it's always obvious where you first folded it. You go like that. She's nice. Nice. So yeah, just double check your polarities right. We've got the positive side actually going to the cathode, which is what you want, and the negative side going to ground. So all good. Same with these ones. Just a bit of a curve. About 1.5 inches, something like that. Fold them over. There's a bit of bastardry we have to do underneath the board there because of the weird setup with the non-stock looking riveted standoffs. Such a weird way of doing it. And it looks shit, but oh well. That's what we've got to deal with because it's what someone else did. Let's, since we're doing a cap, we've got a recap, we've got the board out, let's replace these two radials as well. There's nothing wrong with them, probably, but while we're in there and we've got the board out, may as well change them out. Interesting. One of the leads just fell off, and it's a good thing I decided to do that. It was probably hanging on by nothing. Yeah, wow. It's actually, you can see where it's been arcing there before. Oh, I'm glad I looked at that one. So there's a bit of the lead snapped off physically, so it's not like a pull out from heat from the soldering iron or anything, and you can see there's a little bit of like smoke residue there next to the pin where it's been arcing and sparking. So I'm glad we pulled that one out, and it's the sand wire anyway, and they're not the best. So the only issue with this is just make sure we put them back the way they came out instead of having to trace the whole circuit. So I'll just put a little text to mark there. Future text, black for negative. That one looks like it's on the way out too, like the lead's got a bit of like a notch in it, like a bit of a, something's taken a bite out of it, possibly whatever formed the leads. Anyway, glad we did that. I have to fish some 2200 mic 16 volters out. So that's, I believe, tapping off the heater supply to give a low voltage supply to the cold cathode tube inverter boards. It's just, there's a lot of weird stuff on this. Like they go all out with quality, and then they do stuff like this. Unless it's a previous repair, I don't know. But like, look how much of the lead's poking out. You don't do that. And barely any in the board. It's like it's just tack soldered right on the tip of the lead. So all of them I'll fix up. That's actually the speaker connection too, so that's reasonably important. Anyway, well, I feel like we've battled on a little bit in this video, and I think I've got a delivery coming, so I'm going to piss off, but thanks for watching everyone, and I'll talk to you later.